GM, everyone. Oh, who killed my lo-fi? Probably gonna give it a few minutes for people to trickle in. We got a Zoom in the chat here. Yep. No. Giant Kin, are you able to get a Zoom going for screen sharing? Come on up, DeFi. I got you slated to go first, unless you object.
I always press that exit button instead of join the stage.
So easy to do. Nice. All right, so the Zoom is up. I must have missed it with the memes.
Alrighty, let's keep the lo-fi radio down. I'll share a screen.
Yeah, welcome everyone. We got some really good stuff to share today. Been some good progress over the last couple of weeks. Big push to get V2, which you're going to see the progress on today, to state where it can be live and ready for people to use. So with that, we'll have DeFi start us off. He's going to talk some about our integration of Cape, which is a standard for identifying assets, into V2.
Just trying to share a full screen here on Zoom. All right, we're just going to have to do a browser at a time. All right, so I'll start with sharing this. Everyone see this okay?
Yes, sir.
Cool. All right. So just like when I talked about the types, I think 2 weeks ago, I want to kind of give the motivation for what capes are and why we want to use them. So typically, like when you're building a DeFi application, they're usually like for a specific chain. And so when it comes to identifying assets, it's relatively easy because you've got some unique stuff like, contract address is an easy way to identify an asset. But ShapeShift has always been, chain agnostic. It's kind of been our core business to deal with multiple chains at the same time. So, using stuff like symbol or contract address, when you're dealing with multiple chains, multiple networks, multiple layers, we need a more robust way to uniquely identify an asset or a blockchain in a way that's also going to work with vendors as well. So, Mr. Nerdhair, the security workstream leader, pointed us to this proposal. Basically, they're draft standards for describing, blockchain projects. So it's CAPE stands for Chain Agnostic Improvement Protocols. So they've gone and drafted a bunch of these different improvement protocols, but the ones that we specifically started with were the blockchain ID specification, which is CAPE 2, and CAPE 19, which is the asset type and asset ID specification. So they're really pretty straightforward. So like they give you, if you're talking about a blockchain, It's just a combination of a namespace and then a colon and a reference. And so the examples I give for this, for example, if you're referring to Ethereum, it's simply like EIP 155 colon and then 1, where 1 is mainnet. I think 3 is Ropsten, and then 4 is Rinkeby. So we have a way in a single string to identify that. And similarly for Bitcoin, so they've got BIP122, a colon, and then this is the first 32 characters of the Genesis block. So with this string, you've got enough information to kind of go back and forth and to be able to parse this. So we implemented this. Well, first of all, we looked for an implementation. We couldn't find one. So we've implemented Cape 2 and Cape 19. So Cape 19 builds on top of Cape 2. So you've got a blockchain spec plus then a slash, and then you've got an asset namespace, and then a colon, and then an asset reference. So I mean, it might sound scary, but if you read it, for example, like this is plain Ethereum. So it's like this is the Cape 2 bit with a slash, and then slip 44 and 60, which is like the BIP32 params of the hardened path. And similarly for like DAI, or you could use this example for Fox. Ethereum, mainnet, ERC20 token, and a contract address. So we basically went and implemented this stuff. So I'm just going to share a different window for a second. I'm going to go to our implementation of this stuff. So, all right. So we've created a package in lib called Cape. And within Cape, we've got our implementations of each one with tests. It's kind of actually easier to sort of read the tests and see. So internally, we already kind of tried to come up with a way to solve this. So we've got these thing called chain types, which has got like Ethereum or Bitcoin at the moment. We've got network types, which is, like mainnet, testnet, Ropsten and stuff like that. So we wrote a bunch of tools specific to our use case that allows us to take our IDs that we're using internally, so we don't have to make any breaking changes at the moment, convert them to a Cape 2, and we get the string back out. And then similarly, we've kind of got the opposite. So like this is the same Cape 2 for Ethereum. We parse it back out and we get the chain and network that we expect. And then similarly, we've got the the same thing for Cape 19. So you can give it plain ETH. So ETH doesn't have a contract address per se. So just giving it a chain and network, we're able to get out the Cape 2 for ETH, and then we're able to get out do the reverse basically for this. And similarly, like we can make a Fox Cape 19. So given a chain network, a contract type of ERC20, and a contact address, we can build these, and then we can do the same thing in reverse. Now, this is kind of useful because it means that we've got internally within all of our systems now, we've got this way to identify assets uniquely across chain, network, like token type, and the contract address. And so the issue is, and we experienced this with our previous, the beta.shapeshift.com version called Axiom, where we used a thing called an identifier, and we just came up with these strings, right? So we called, Bitcoin was just Bitcoin, Ethereum was just Ethereum, but then, we had, different stuff for, like ETH on Thorchain, for example, or ETH on Plain Network, or, like wrapped ETH. So we wrote these adapters. So we've got one now for CoinGecko. So CoinGecko does the same thing as we did in Axiom. So they've got their own internal IDs, but we don't want to have CoinGecko's IDs kind of leaking all throughout our application. So, we want to be able to pull data from multiple different sources all over the place. And, we don't want all these different IDs and try and match them up. So we wrote these adapters that basically sit at the network, like at the network boundary. So when we pull in these, the parse data stuff is probably most useful. So when we grab data from CoinGecko, we're then able to, we know like that specific API talks about ETH and mainnet and ERC20 tokens. And so we're basically able to replace their CoinGecko ID with a Cape ID. So now we're able to pull in this data from all these disparate sources and refer to it in the same way. So basically, then we all of this kind of like vendor specific stuff, if you want to consider CoinGecko a vendor, it's right at the boundary of our code. It's got good test coverage and stuff. And then we can pass around these IDs internally. And so when it comes down to building like this cross-chain interface where we're going to be plugging into, like Solana and, the Binance chain and Ethereum and all of these other different networks with like the same kind of assets on them, or different assets, we have a unique way of identifying them. So the intent for this Cape package, it's currently living within lib and it's kind of coupled to our implementation of it. But what we'd like to do is, isolate our specific stuff where we're talking about our types of like chain and contract and network, keep that inside our package. And in terms of our implementation, it's really simple. So we'd like to open source all of this in a separate repo, basically. So like we would define all these namespaces and references, and similarly for Cape 19, so like the asset namespace, the asset reference, export all this stuff and make this available to the community as kind of a contribution that we can use. But getting this kind of this, I think, as like Willie said in the stage chat, this is not the sexiest demo for non-engineers, but anyone that's worked on our code base and known that, like, how to identify like what you're dealing with, it's a tricky problem. And if we get this groundwork in first, then it's going to really set us up for an easy way to pull in data from all of these different sources and not have to worry about how CoinGecko or Uniswap or CoinMarketCap talk about their assets. So we've got a consistent way to talk about it internally, and for the community as well. Like this, an implementation of this spec is going to be super useful because I think everyone pretty much firmly believes in a cross-chain world at this point. So yeah, that's what I've been kind of sneaking in slowly without trying to make some breaking changes, and I hope it's going to be pretty useful for us to be able to bring more chains on and identify all of our stuff in unambiguous ways. So happy to kind of answer any questions around this.
Awesome. Thanks, DeFi. If anyone in the audience has a question, you can raise your hand and we'll bring you up here.
Sweet.
Yep, super useful stuff. As people who have worked in a technical capacity in crypto are probably aware, everyone seems to have their own way of identifying assets. Exchanges typically are using symbols, which we know are not unique. Anyone can come along and create an XYZ token on Ethereum, and it really creates havoc that there hasn't been a standard way to make sure disparate parties are communicating about the same asset. So I'm pretty excited to see the spec, and I'm very happy that we're going down that path with V2.
Yeah, it's a super good point that I forgot to mention. It's actually minimizes the security risk as well. Anyone can create their own contract on any network, say ETH with like the Fox symbol, and if they manage to sneak that into some upstream data source that we use, they might be able to like get our system to pick up the wrong Fox thing and basically get people to send the wrong address or swap to the wrong address or something like that. So this definitely helps mitigate that as well.
For sure. All right. Thank you, DeFi. Next, Almut's going to show us some of our progress on BTC support. I sent you an invite. I think you just need to accept it. There we go.
Hey, can you guys hear me?
Yep.
Okay, cool. So yeah, I'm going to demo our work on BTC so far. It's 90% there. I'll just share my screen and get going. Let's see here. Oh, can I only do browsers or can you do full screens in this thing?
I think DeFi had the same issue. He was trying to do full screen. I don't know if whoever's adminning the Zoom, is there a setting that's preventing full screen sharing versus single window?
I want to do window really bad.
Yeah, so otherwise you're going to have to keep unsharing and sharing a different window.
Well, let's see.
Why don't we start off with single, and if anyone's able to help out with that, it'd be great. Maybe we'll only have to switch once or something.
Yeah, okay. Let me see if I can find the right one. Okay, can you guys see this?
Yep. Looks good, man.
All right, cool. So I was one of the ones working on adding Bitcoin support along with Sterling. So yeah, basically we did this by adding a new chain adapter to our lib library. And I'll show you that. Wait a minute. Host has asked you to start your video later.
Maybe
so,
this means it's fixed up, so you can do the full share.
That's okay. I'll just keep going here.
Yep.
Yeah, so we basically did this by adding a new chain adapter to our lib library, which we've talked a little bit about. Basically, the idea is hopefully no modifications or very minimal modifications to our web are needed, and then we can add new chains to lib, which I was going to show and I'll show in a minute. But by implementing the chain adapter for each chain, which specifies a certain API you need to follow, like transaction history, sign transaction, build transaction, we're able to add new coins super easily, which is what we did here. 90% of the work was in the lib library, adding the chain adapter, and then a little bit of massaging the web here to get this to work. But hopefully in the future, that'll be less and less. So let me just demonstrate what we've got. You can see Bitcoin showing here with my balances. Yeah, Bitcoin, send, receive, all this stuff. Balance. One big thing, a large chunk of the work here, especially on the web side, you'll notice on Bitcoin specifically, we have these three buttons: Legacy, SegWit, SegWit Native. So it's pretty cool. In our mobile app currently, we only support SegWit Pay to Script Hatch, which here is marked as SegWit. So we can actually now support all three of the standard types. So like if we import a mnemonic from mobile, you can go to the SegWit type here, get your balance, do receive address. You'll see that that's the 3 type of address, which corresponds to, if you know about Bitcoin or some of the more fun technicals, the SegWit P2SH type. Or if you want to check out your legacy address, see, notice the balance change, one address, SegWit native. And this is kind of like a global switch we implemented in the app to keep it simple. So anytime you switch one of these from the Bitcoin page, you'll see, if I go back to the dashboard, now it's showing this balance here. We did that just for simplicity. Once you switch, it's kind of set globally, kind of how we did that. But let me just demonstrate, I guess, a send between one of my different address types, show that this is working. So I'll get my SegWit address. You know what, I'm going to turn touch to talk off. This is annoying. All right, cool. You guys hear me?
Yep, you're good, man.
Okay, cool. Yeah, so I'm going to send to my legacy address from my SegWit, just demonstrate basic send functionality, show this thing's working. Here, this is some to-do. Basically, we're not quite validating addresses correctly. I think it might only be trying to validate Ethereum addresses, and actually, it's not even really validating Ethereum addresses correctly, but that's fine. Clicking this button still works. Should be checking the address is correct, but it still works. So just send $1. That's easy from my SegWit native to my legacy. fees, this is another area. It should be pretty easy to do. It's just all showing 0, but right now we actually it's hard coded to 4 satoshis per byte. That's another to do in the Bitcoin chain adapter. We have the backend work done in Unchained to estimate fees or get fees at any given time. We just kind of need to wire that up to the Bitcoin chain adapter. Should be pretty easy. So, and then get the front end actually showing the values. But no matter what I click, it's going to do 4 satoshis per byte here, just because that's a to do. And let's send this transaction. So we should be able to check. I didn't get a TX ID, but we should probably add that. I can look at this address on chain though and see that we are pending to receive some Bitcoin. So there's unconfirmed TX from Bitcoin address to my one address. Yeah, it's working. So that's about it. I could quickly show the chain adapter in lib and kind of what's there, what's missing, but I feel like we've talked about chain adapters in the past. I don't know if that's worth it, but that's kind of the demo. Another to-do is...
Was that SegWit native to Legacy?
Yeah, that was SegWit native to Legacy, so you can see.
You're able to go between all 3 types there.
So we could go like
send and receive.
Yeah, so we could go like I don't know what's wrong with it now.
Bitcoin fees are actually halfway reasonable at the moment.
Yeah, I kind of looked up the fees before this call since I was hard coding and put it at 4 sats per byte. It's not bad. It's a lot better than ETH.
And this has all been native wallet?
So this is all the native wallet. Yeah, this is all your mnemonic that's stored in the browser locally. I haven't tried with keep others, but yeah, it'll work with any wallet. The abstraction doesn't care about what wallet you're connected to, theoretically.
Yep.
But yeah, I mean, I could demonstrate here, like receive SegWit native. We're gonna send from SegWit. Bam, invalid address. That's not true. And USD amount $, just to save money. And bam, we've successfully sent.
Nice.
That. So then we could see this SegWit native address on chain. Should have a pending TX, pending incoming TX. Yeah. So
very cool. And we've got the pay to script hash SegWit covered. So when we get this up and live, people will be able to take, say, mnemonic from their mobile wallet, import it here, and access their pay to script hash SegWit Bitcoin, since that's what current platform does by default.
Totally. And that's what this middle one is. I don't know if we want to rename it or whatever, if we have better names for these. This is just kind of what we put here. But yep, you'll be able to access it right away and switch between them or do whatever you want. Maybe consolidate them all into this one.
Cool.
Yeah, so that's about the demo. Any questions or anything from anyone else?
So you pointed out like the address validation and the fee stuff. What else is left to do before you feel like calling it done as software can be?
So I can think of the big ones are transaction history. We already have that. That's not working on Bitcoin. It just throws unimplemented with this WebSocket that gets transaction history from Unchained, but that's implemented for ETH. So that's probably the biggest one. But since we have it done for ETH, we at least have a template to go off of for how to get that. And then, yeah, that and fees, I think, are the only ones I can think of right now. We're pretty much there.
Cool. So, the history, that's work on the Unchained side of things?
Potentially, I'm guessing it might be some massaging of formats. Kevin might know more about that than me, honestly. I haven't looked into it yet, what exactly needs to be done, but it comes from Unchained. I know that.
Cool. Yeah, if anyone's got questions for Elmot, raise your hand. We'll get you up here. If not, TechnoJack or Theobald, if you're out there, how would you feel about giving an update on urine? See your hand raised. Thank you very much, Elmot. It's awesome and great to see.
Awesome. So we're starting to work on the urine integration. Right now, we've got most of the deposit side UI wired up. Or the UI at least hooked up, and we're starting to do the wire up now. So I was just going to do kind of a quick demo and kind of show sort of how earn integrations in general will work, as well as what the current UI is. Go ahead and share my screen. Awesome. Can you guys see my screen okay?
Yes, sir.
So the main connection point to like looking at a staking or vaults is going to change. This is just kind of a dummy trigger that we're using right now just to kind of go into the flow. So all of the earn integrations will be handled inside of a modal. So if you were to say like hypothetically, if this was a USD urine vault, it would say like vaults USDC. When you click it, you'd get dropped into this screen. So this would be for deposit. If you were to hypothetically be on an actual earn page and you wanted to go to withdrawal, you can get dropped directly into the withdrawal modal just by changing this part of the URL. So when we toggle here, you can see it switches to the URL. Any specific information that we need about this vault also gets stored up here in query parameters. From here, you could select an amount. This wallet, I don't even have a wallet connected right this minute. All of the ephemeral data that is actually happening in this form is wired up now though. So like setting your slippage, all of these things. From there, you could then press continue. Of course, this is probably where it errors. Curse the demo. Yep. Weird.
Somebody's got to do it. Thank you,
Yeah.
TechnoJack.
I believe that's because I have 0 USDC in this account. So it was trying to access balance of undefined. So little edge case to handle there. Let me go ahead and set this up to do this. So when you do connect your wallet and then hit next, you can go into the approved screen. The logic on click here will actually check if you need an approval, and if you don't, it'll just skip past step number 2 and drop you directly into the confirmed deposit screen from here. This isn't actually wired up yet, it's just mock data. And then from there, you would actually be able to sign and broadcast, and here you could watch the transaction broadcasting. Again, we'll see the very similar flow for withdrawal. Right now, it's just kind of in a dummy state. And these buttons here will eventually get updated. They're just kind of placeholders. So that UI still needs some update. The big thing with this is this modal basically works by just pushing to a new route, which is kind of cool. So if we were to have different vaults in the future, it would still live at the earn with the earn type of vault and a different provider. So this provider here is what determines which manager to use. So right now there's like a urn manager. If we were to switch this out to be like liquidity providing, it would be earn/liquidity/Uniswap. And then whether you're adding or removing would be the different action. And then any specific information about that could then be stored on this query parameter. So this becomes kind of our state management / source of truth for interacting with the different earn managers. This kind of gives us a nice little modular plug and play approach to being able to load in different earning types and earning opportunities as the app grows and evolves. All of these UIs here can be reused. They're dumb. They don't know anything about the manager that's using them. So in the case of Yearn, there's no Yearn specific information in here. It's just a form. And when you hit continue, it passes that state back up to the parent. And the same is true for all of the other screens. Again, this, you just pass some data down about what it should look like, and then the confirm is just a callback back to the parent. So we can just re-render each one of these screens and each one of the subsequent managers for different earning types as we kind of move along, which I think gives us some of the most reusability and hopefully doesn't lock us into any kind of weird corners where we're like really coupled to a specific provider. So that's about all we have thus far. Hopefully by end of day today or end of week, we should have all of the deposit flow done. And then next week should be doing the withdrawal, which should go relatively quicker just because there's no approved process for that. And then just kind of doing the actual in-app integration. So updating where these triggers are. So there'll actually be an earn screen and you can look at different earning opportunities there, as well as on each individual asset that is a supported earning type. Does anybody have any questions?
Awesome. Really good to see progress here. How's your experience been interacting with Yearn, sort of the blockchain side of things?
So far it's been pretty good. We've got a Yearn API manager. It's relatively simple. There's basically an approval call, an allowance call, a deposit, and a withdrawal. So from an interaction standpoint, that's pretty simple contract calls. There's a few other methods available on the contract to like look at total balance and a few other things. The only issue we found is looking at trying to figure out what the APY is, and their API is available, so we're just pulling that from their API since they're kind of calculating it, and it's like a rolling average based on, I'm not sure exactly the timeline, maybe it's a 7-day rolling average, not 100% on that. So instead of us trying to calculate it and keep track of that data, we decided to leverage their API to get the APY for each vault that we're going to support.
Nice. Sounds good. Any other questions on Yearn? Go ahead and jump on up here if you can, or raise your hand and we'll bring you up. Cool. Well, thank you, TechnoJack.
Yeah, thank you guys.
Great. Next, we've got Ryan here. He's going to show us 0x integration in V2.
Hey, GM, everybody. Can you hear me?
GM.
Perfect, perfect. So yeah, thanks again, Adam, for the introduction. So Toshi and myself have been implementing 0x in V2. 0x, if you're not familiar, is a Ethereum DEX aggregator that we can then in turn use for swapping. So what we were tasked with is to implement this into V2 to get it working similar to what you would see in beta.shapeshift.com. So can everybody see my screen?
Yep.
That's
good, man.
Perfect. All right, so what we have here on our right side is our trading component. Basically, what I want to show is a trade into Fox, and then we're going to actually approve Fox for trading back into ETH. So go ahead and trade ETH. Now this is some implementation that we get the quote similar to like on beta.shapeshift.com, get the quote as soon as the user stops inputting, and then it populates both input fields. So we can click preview trade. And this gives us the ability to confirm the trade. So right here, as you can see, we have 0.01 ETH for 96 Fox. The rate is currently right here. The miner fee, it seems slightly high but the actual implementation of the quote is using the correct fee. So it's something about our interface, and so we have to kind of get that together. Although that could possibly be potentially at around that level.
Is that
So yeah.
showing worst case estimate based on the gas limit?
I believe so. Yeah, I believe that we definitely want to show worst case as opposed to showing less and then it actually be $123. So
For
yep.
sure.
So then I'll hit confirm trade, and we have a trade complete. We can go here to view the actual trade on Etherscan, and you can see that it's actually pending. So yes, so that flow is currently working. Everything is broadcasting, and as you can see, the value, and then for right now, as you can see, the cost is correct. So I guess it's one of those things that kind of randomly happens, but we're definitely looking to flesh that out. But as you can see right now, we have a trade complete. Wanted to kind of check to make sure that this is finished so that we can actually trade back into Fox.
And what did
Wanted
that
to
fee
show
come out at?
The fee actually came out as 123.44.
Yeah, 40.
Actually no.
93.
See, yeah. Yep.
Cool.
Yep.
Okay.
So it came out as 93.
A little better.
Right, exactly. I'll definitely take 93 over 123 all day. So yeah, now that that's complete, we'll go ahead and swap back. So we'll do 90. That'll give us the actual amount. Hit preview trade. And since Fox hasn't been approved, then it'll take you to the actual approval screen so that we can actually in turn interact with the Fox contract. So we can hit confirm here. And as you can see, it is approving. We have the transaction for the actual approval right here. And that is pending. So once again, the estimated gas fee, probably not going to be $91. It'll probably be around half of that. So that's just same thing, something that we kind of have to flesh out.
Do you know if we're using the EIP 1559 fees in V2? I think that got added in V1 recently, and I'm just curious.
Great question. I mean, we're using Unchained, and if Unchained is using EIP 1559, then I think that we're using that same thing. So, but not 100%. Kevin could talk more to that.
The TX buildings client side now.
Yes,
so I would think it would be up to the client. I mean, you have to get the recommended fee data for whatever format. It's got to come from somewhere.
Once that TX confirms, if you go back to Etherscan, you can actually tell because it'll tell you what type of transaction it is if you refresh that.
Yeah, that's right, under details there.
So actually, yeah, that one right there says legacy. So that one was not EIP 1559.
Cool. Yep. Something for the to-do list.
Yeah, for sure.
Jot that down now.
Cool. So waiting on this pending. And usually it will come back as long as we have the TX hash, then we'll be able to have that completed.
I need to refresh it.
Yeah, let me see it. There we go. All right. So yeah, so now since it's completed, we can actually go and confirm the trade. Hit confirm trade. Expense builds. Cool. So it went through, trade is complete, and then we can actually view transaction on chain and just wait for the actual pending. So yeah, so things to do currently. The sin max is not currently implemented quite yet. It's getting close, but not fully implemented. The way that we actually implemented the 0x swapper gives us the flexibility so that then when it is time to bring in Thorchain or any other swappers, then it should be a lot heavier, a lot lighter of a lift. And yeah, so from there, as well as another thing that needs to be implemented is bringing back transaction history data. So that's kind of in flux as well. But yeah, that is 0x swapping in V2.
Awesome. Thank you, Ryan. As
Yeah.
far as, I guess first I'm curious what the actual fee ended up on the approval TX. I think it said 90 as the estimate.
Yeah, this is the trade, the approval 42. So what we've been seeing is that it's about half. So and it's like I said, it's more so the front end calculations. So we need to look into that and kind of see exactly why it's I mean, it's literally consistently double most of the time. So
Yeah, it
just looking
might
at the
be
calculations.
we're just being overly conservative with the gas limit, maybe, which is definitely preferable to running out of gas because then you spend that money without getting anything for it. But
Exactly.
maybe we can tighten it down a little, do some research on that.
Right. Right. Yep. So yeah, but like you said, I haven't had any issues with any trades or approvals failing because of the fact that that it is not enough. So so yeah.
Cool. And you mentioned transaction history. So things like displaying historical 0x swaps that have been made by the user is on the to-do list.
Yes, as well as if a trade fails or succeeds, and that coming through the WebSockets, that's something that I believe is a known issue currently, but it is on the to-do list to get that moving so that it can update without us having to refresh or do anything else on the front end.
Gotcha.
Yep.
Cool.
Any other questions?
So we're using a similar swapper abstraction to what we have in like current mobile, current platform. That should set us up nicely for adding to Thorchain, Osmosis, other dexes.
Yes, yes, and shout out to DeFi Cafe. He's really been the person to push as much decoupling as possible. So utilizing a lot of TypeScript types that are specific to a chain, so that when we integrate, um, it the actual process and the flow is not coupled to a specific chain. So as we integrate like different chains and Thorchain as well, there will need to be some slight modifications in the fact of like uh, um, the process, but at the same time, it will be minimal compared to what we had to do to actually implement it the first time. And then from there on out, it should be a lot simple, a lot more simple.
Cool. Awesome. So next, Major Hayes is going to show us some of the progress on keep key pairing on the platform or on V2 platform. Got an invitation out to you. There he is. Thanks again, Ryan. That was awesome. Really, really good to see.
Yeah, no problem.
All right, this will be a quick one, but just showing keep key pairing working. So We're going to click connect to wallet, pick our keep key, pair. This brings up the web USB pairing dialog.
Curious device name.
Yeah. Let's call it an unfortunate firmware upgrade. So yeah, if your device has a pin, the pin modal will pop up automatically. That's verifying the pin right now. And now my device has a passphrase set on it. So I can set a passphrase if I want to. And now it's asking me to confirm on the device. And now the device is unlocked. And at that point, you can see it. Obviously, I don't have any balance on that particular passphrase. So I'm going to reload it and do another one that has a balance. So we'll pair the keep key again. Put in our pin. Set my empty passphrase. This one actually has funds in it. So here we go. One thing also we can do is if you go to get a receive address, you can click verify. And now on my keep key, it says Ethereum account 0x7C6250, which matches there. I can hold the button down on the keep key and you'll see it says verified now. So that part works. The next thing I want to show is just what happens if you like put in a wrong PIN number or something. Okay, so connect keep key. Oh, I gotta, whoops, gotta reload here. Okay, so if I put in the wrong PIN number, the device is going to check it and then just pop up and ask me for the PIN number again. So you get a chance if you type it in wrong to do it right. If you
How many
close
chances do you get? Does the UI make you aware of that?
the device, basically what's happening is the device is sending an event to the web page saying I need a PIN, and it'll eventually just stop telling you that. So unfortunately, there's no good way for us to know if the device has locked you out or anything like that.
I think it goes into like an exponential back off thing where it takes, like it makes you wait longer between attempts.
Yeah, well here, if we, let's repair it and see what happens. So if I do the wrong PIN, it says verifying and then pops it up again on the device. I can see it. And then it says verifying. It's asking me again. And now it has stopped asking me. So the device is now in a locked state and it's not prompting for a PIN. So then you just basically at this point you have to turn it off and back on again in order to be able to get it to
If
prompt.
you just turn it off and on, it'll just let you try 3 or 4 more times. Or does something change with it?
Well, it
Because
goes
I
back.
thought it would like prevent you from just brute forcing pins.
Yeah, that's you'd have to ask Nick on the specifics of what the firmware itself is actually doing. But it looks like it just stops asking for pins after 3.
Cool. Okay.
attempts. So, but that's it. That's basically all there is to keep pairing.
There I go, kicking myself off the stage. Awesome. Thank you, Major Hayes. Thank you to all of our presenters. Unless there's something I missed or someone I missed or anyone just wants to talk about something for a few minutes, so raise your hand or jump on up here. Otherwise, that concludes demos for this time. Thank you, everyone.